come over here like this for the motor. And since it's AC, we use solid lines on both sides. 120 volts AC. Ah! GEIR. Okay, I'm gonna have to pull out my bass and I'm gonna have to set up, I think I wanna set up the big amp, because if you wanna play bass through a guitar amp, you gotta be really careful. You gotta cut down the preamp hard, because bass pickups put out so much more current. So, you gotta kick the, and then you gotta kick the bass down. But, so what you do is you put the channel controls really low, and you control the volume of the master. But, use a big amp if you're gonna do bass. Anyways, did you start yet?
It's been on.
Quack.
For like a minute.
Yeah, okay, that's fine. Anyways, my point was, let's go ahead and call this 60 amps. 60 amps. That's a lot. That's a whole lot. And then if I go in the National Electrical Code, hey.
He's not here?
Christopher Corona, you here? No.
Just take a picture of him. And the teacher.
National Electrical Code.
Oh, shit.
Okay, groovy, thank you.
Thank you.
Oh, good, thank you. So I say it's pretty in and out. Oh, look, he's gonna get punished for not being here. It says right here, National Electrical Code 2002. It's old, but it hasn't changed. The number of the table has changed though, but we're looking at 314.16B. That's 500. So 300 is Article 300. See, this is like the Bible, so Article 100 doesn't go there. All right, 310. Flat conductor cable type. Okay, so 310.16B. It's going to give you all, there you go, 310.16. Allowable ampacities of insulated conductors rated 0 through 2000 volts, 60 degrees Celsius through 90 degrees Celsius, 140 degrees Fahrenheit through 194 Fahrenheit. Not more than 3 current carrying conductors in a raceway cable or earth directly buried, based on an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. You write that down? Okay, allowable ampacity. Looks like we need to. Ampacity. Ampacity is defined as the ability of a wire to carry current. Amp capacity is basically what ampacity is. Now, what happens if I try to shove too much current down a wire? It's going to fry it. Good. Because the flow of current creates heat. I squared R. Current flow, which is like repeating yourself. Current flow creates heat. It also creates a magnetic field, but we'll talk about that later. So, current flow creates heat. And the formula for that is I squared R. What's I?
Ionization?
What's I? Amps. That is correct. What's R?
Resistance.
Resistance. So we multiply amps times resistance, and that's going to give us watts, which is how much heat is created. So that's going to be a problem. So what we have to do then, wrong place, nice. Really? Okay. There we go. That. Sure. Yep. Current flow creates heat, so if we try to shove too much current down a wire, it's just gonna melt, right? Most conductors are made of what material?
Copper.
Copper. Somebody told me, why do you think Asian people walk like this? And you know what, I think they walk like this because it pulls your shoulders back. You see a lot of people that are like this, right?
Hunchback.
Pull your shoulders back. No, hunchback's different, that's a curvature back here. But a lot of people's shoulders come in because your chest muscles are stronger than your back muscles, right? Anyway, they carry a lot of tension, you can tell people are under a lot of stress. Anyway, my point was, that's what they said, I didn't say it. So, what are we given in este ejemplo? We are given 120 volts, right?
Mhm. That's
And
right.
what else?
Amps.
60 amps.
600.
That is correct. So, like I said, I don't even do the hard way, I just do it this way. Especially since all the numbers were specifically picked by me to be easy. Alright, 120 divided by 60 is what? 2 is
Two.
correct, thank you. 2 what?
Ohms.
Ohms, correct. Okay, 60 times 120 is what? Don't make me get out my 5th grade chart. What's 6 times 12?
So what, 7,000? 7,000.
That is correct. It's gonna start with a 7 and a 2 and it's got 2 zeros, so that's gonna be 7,200. 7,200 what?
Watts.
Watts.
Because of power, right?
Mhm. That's right.
Okay. So if I was running like an air conditioner or some big thing like a dryer or something like that, if I was to run it on 120 volts, first of all, you're probably not gonna find a 60 amp circuit at 120 volts. They just don't do it. Why? Because the wire size would have to be huge. So, I bring out the National Electrical Code, which is the rules for electrical installations in the United States, and it says that in order to carry 60 amps, I need to have a number 6 wire. Yeah, that's a problem, because number 6 wire is pretty freaking big. Now, you'll notice, okay, which is bigger, a 20 gauge shotgun or a 12 gauge?
20.
12.
12.
Yeah. Okay, so this is gonna go like this. I like these drawings because I think they look kind of like what I'm trying to talk about. Drawing wires is easy and fun, and it's always nice when your drawing kind of looks like the thing you're trying to draw. Alright, well anyway, the thing is that this conductor is way smaller. Now, why do you think I would want to use a smaller conductor?
Less resistance.
Ooh, first of all,
resistance of flow.
the conduit, which is the pipe that it goes in, can be smaller, and that's cool. Plus it'll fit in smaller spaces, which is also cool. And, what's that conductor made of?
Copper.
Copper.
Okay.
Nope.
The conductor's made of rubber?
No.
Copper.
Oh, thank
Copper.
God. That is correct. So, ah, that's not what I wanted. So, great drawing. Anyway, my point was, this is made of copper, and while copper is relatively cheap, it ain't free. In fact, you'll find that copper is pretty expensive. In fact, copper is so expensive that thieving trash
Go.
will go out in the middle of the night and
Cut the
risk their
Tesla.
lives to cut the freaking wires so they can take them, what? What
So
about
they
it?
can have all the moolah.
Like this, yes. Yes, they'll go ahead and steal something, they'll get $60 for it, even though it costs $10,000 for the city to replace it. Which is why you can't have nice things in freaking neighborhoods like this. See, this is a big thing. That's 500 kc mill, I think, might be 600, whatever it is, this is big. And it represents a lot of copper, and a lot of copper means a lot of expense. Well, I used to have a piece up here, but, I don't know, whatever, I don't need it. So the primary reason we want to use smaller wires is because copper is expensive. This stuff, well shoot, I don't know. All the prices I knew were pre-COVID. And this was like 75 cents and that was like $1.50. Because it's way bigger. So, here's why that matters. I'm going to have the same coming into your house, there's two voltages available. One is 240, one is 120. You say, well, why would you have two voltages? Well, let's look. PEIR. If I run the same appliance, which is to say it consumes the same amount of power, if I run the same appliance, because two similarly constructed appliances consuming the same amount of power should be doing the same job, right? Okay, but now the voltage is 240 volts AC. Now how many amps I got?
30.
30.